Hello. Uh, hello. 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 Hello everyone, a very good afternoon to all dear students. Very good afternoon to all dear students who have connected online as well. Good afternoon Siddharth, good afternoon Bulbul, good afternoon everyone. Okay. So today we are starting with the next session of your Prelims Crash Course, that is with respect to geography topics, which is a part of your Sambhav program. Okay. So today I am going to continue forward from the topics that we had covered yesterday. Those of you who couldn't attend the class can always watch the recorded session, okay, which is available on the YouTube platform of Sunya IAS. Okay. Chalo, let's start the discussion for today's topic. So today we are again continuing with climatology part 2, and let's do a quick recall of what topics did we study yesterday. So yesterday what we had studied, कल हमने पढ़ा था क्लाइमेटोलॉजी, तो पढ़ा था, उसमें क्या पढ़ा था? सबसे पहले हमने कहाँ से स्टार्ट किया? टेम्परेचर. कहाँ से स्टार्ट किया? सीक्वेंशियली. कंपोजिशन ऑफ एटमॉस्फेयर, देन वेरी गुड, देन winds, yes, pressure belts, jet streams, planetary winds, local winds, regional aspects of the winds, then upper tropospheric winds, and then precipitation, types of precipitation on which we had ended. Clouds, okay, type of condensation, forms of condensation, etc. All of that we have covered. Now let's move forward for the topics of discussion for today, right? So today we'll be taking up forward the discussion with respect to these topics, okay? So ITCZ, which we have done already, polar vortex, monsoons, air masses, Walker circulation, and teleconnections with respect to monsoons in context of El Nino, La Nina, IOD, etc., and some discussion on cyclones. So this is how we will be forwarding in the today's class. Okay, chalo, let's start the discussion. Now ITCZ I had covered in the last class. I will be covering in context of the monsoons only. Okay. Now write down the first heading, that is polar vortex. Polar vortex. Now what is a polar vortex? So polar vortex refers to the counter-clockwise flow of air that helps keep the colder air near the poles. So this is a counter-clockwise flow of the air near the poles. Okay, so where it is in the upper atmosphere near the poles in both the hemispheres. Okay, so this is a polar vortex, which is a cyclonic flow, okay, counterclockwise flow, okay, of air, that is wind, counterclockwise flow of air, okay, yes, yes, wind कह रहे हो ना? Yes, yes, ठीक, okay. So see, now at the poles, okay, On surface we have the high pressure, so it is associated with the low pressure aloft, and that is why the anticyclonic circulation, because the wind is moving very fast in this area without any obstruction, so that is why it is very fast circulation. So you can imagine it to be like the winds which are moving in the anti-clockwise direction aloft near the poles. So that would keep the cold air near the poles itself? Yes. So the cold air that is contained near the poles. So cold air is contained here. Now this is a normal year, a normal time period. Okay. So here what do we see? The Arctic air over the North Pole. Okay. So this is associated with the low pressure and the cold air surrounding both of the Earth's pole. Okay. Now see, it is very prominently developed during the winters because the contrast is very great, right? But there can be certain conditions when this polar vortex will disrupt. Okay. In the normal years, when this condition is sustained, then what will happen? The cold air will be contained near the poles in the upper atmosphere, right? But in certain years or during the certain time period, okay, this polar vortex can weaken. This polar vortex can weaken. So for example, when we witness sudden stratospheric warming, which we call as SSW, okay, so there can be the sudden stratospheric warming. Okay. So warming associated with the stratosphere. Now in that condition what can happen? This polar vortex which is contained in the upper atmosphere near the poles can weaken also. So this circulation will get disrupted. So that is termed as the disruption of the polar vortex. Okay. So now this is the condition 2. This is the disrupted polar vortex. This is the first condition. This is the disruption of the polar vortex. Now when this polar vortex is disrupted, so it tends to shift a bit southward. When it would shift a bit southward, it also impacts the jet stream, right? So this is the jet stream which is the polar jet stream. Okay. So we remember this is the path of the jet stream, but now the meandering will be there, right? Yes. So because of this meandering, what would happen? The associated weather conditions will get disrupted across multiple regions. I hope this is clear to us. Because the jet streams, they will also have the crust and the trough as well, right? So wherever this polar vortex expands, then what would happen? The cold air would expand as well. So this expansion can result into extreme cold conditions sustained over multiple days. Okay. अब क्या होगा इसको ध्यान देना है. This polar vortex shift so disruption of the polar vortex. especially parts of North America. This can result into extreme snowfall conditions, sustained over multiple days, across week also. So there can be heavy snowstorms. Sometimes have we heard about this during the winter season or not? Yes. न्यूज़ में आता है कि नहीं, नॉर्थ अमेरिका के क्रॉस बहुत हैवी स्नोफॉल हो रहा है किसी एरिया में, स्नो स्टॉर्म्स हो रहे हैं. वाई? बिकॉज द पोलर वोर्टेक्स इज डिसरप्टेड, which can bring in heavy snowfall across parts of North America, right, for which is sustained over multiple days. Okay, this is one of the reason. So we are discussing about the polar vortex. Okay, and what is the normal condition and what is the disruption. So in the normal year, what happens? That is, the cold air is sustained near the poles in the upper atmosphere, whereas when it is disrupted, then the cold air can invade parts of North America, okay, and also disrupts the jet stream. So jet streams can have a meandering path now. And why it is becoming more important a phenomena? Because of the global warming. We are witnessing more and more such events. Okay, so this is getting intensified because of global warming. Okay, so it can bring in snowfall, snowstorms, etc., which can be sustained over this region, okay, over multiple days. Simple. So whenever such questions come, for example, even the questions on climate change can be associated with this. Okay, even in the mains this is very relevant. Okay, definitely in the prelims nowadays, because of the type of questions they are asking. Okay, so this is another diagram to show you the same perspective. That is the cold air which is contained here, while when there is disruption, then the cold air moves southward. Simple. So cold air moves southward and this can lead to heavy snowfall. That's it. Okay, so this is the same diagram, just showing in blue the heavy snowfall and the cold air conditions. Now the jet stream has become wavier, so there can be the associated high pressure centers also which develop, right, which we had studied yesterday. So a high pressure center bhi sustain ho sakta hai over multiple days, because now the jet stream is wavier, it has meander. Okay, so I hope this is clear to you. The wavier, okay, that is meandering of the jet stream. So jet stream, see, jet stream can have the zonal flow, right, then there can be meandering. This is wavier or not? Yes, yes, this is a wavier jet stream. This is a meandering path. And when it meanders further, it can result into this type of path as well. Okay, I hope this is clear. So wavier because it is now wavier, right? Okay. So you can see in the 3D animation as well. Okay, so the invasion. So this is what causes cold temperatures across parts of US. Next, write down Indian monsoons. Now Indian monsoons is very important. Okay, very, very important topic, because multiple questions are asked around the topic of Indian monsoons. So today we will learn about Indian monsoons, and if you will be attentive for the next 1 hour or so, you would learn Indian monsoons in a manner you will never forget. ठीक है, आपको एकदम conceptually clear हो जाएगा. हाँ, yes, yes, I mentioned that only. See, polar vortex 10 to 30 miles above surface. Okay, jet streams, they are relatively lower. Polar vortex is high up. Okay, That is why I mentioned in the beginning itself, that is in the surface what we are witnessing across the poles, that is जेट स्ट्रीम. अगर आपकी देखो जेट स्ट्रीम की भी इंडेक्स साइकिल है ना, तो व्हेन जेट स्ट्रीम इज हैविंग द zonal flow which is a normal flow, I'm talking about the interaction which happens between the polar vortex and jet stream. So polar vortex in the normal conditions would be contained there. Okay, so imagine like this, it is contained here and this is the jet stream. But when they interact, then what type of the changes in the weather phenomena happens, that is what I have explained. But otherwise also jet stream will have its own impacts, right? That we know. Okay. No, because of the disruption of the polar vortex, there was an impact on the jet stream, right? Polar vortex disrupted because of the events like sudden stratospheric warming. Okay? Okay? Okay. Now next, Indian monsoons. Now see, there are multiple factors which are responsible for the Indian monsoons. And generally when we talk about monsoons, we refer it to as the reversal of the winds. Okay. So now when we talk about monsoons, what is monsoon? Monsoon is a climatic phenomena characterized by the seasonal winds shifts that bring heavy rains to the Indian subcontinent. So generally we term it to as the seasonal reversal of the winds. Now actually, do the winds reverse? What happens? What is the mechanism? Let's learn that. Okay. Now when we talk about the Indian monsoon, so this is kind of a map which is easily available. Every time you see this picture, that is the southwest monsoon winds invading parts of India, and then we have the monsoons. But this is not the characteristic which develops throughout the year. पूरे साल क्या होता है उसको समझते हैं. Now see, monsoons are further divided into two parts. One is the most important monsoon season, that is the southwest monsoon season. Okay, so southwest monsoon season, but apart from that there is also northeast monsoon. Okay, so when we talk about monsoons, they are southwest monsoons and the northeast monsoons. And this is very important because 80 to 85% of the rainfall throughout the year that is received in the southwest monsoon season. On an average, we are receiving about 115 centimeters of rainfall throughout the year. ठीक है, 115 सेंटीमीटर्स के आसपास हमारा एवरेज एनुअल रेनफॉल है. उसमें से 80 to 85% वी आर हैविंग इन दीज 3-4 months. Okay, so average precipitation is around 115 centimeters per annum across India. Okay, so one is southwest monsoon, which is depicted here, presence of ITCZ, and there is also the reversal of the winds, which results into the retreating ones. Okay, retreat of the monsoons. So these are the two seasons. Now apart from India, so India definitely has certain advantages because of which the monsoons are well developed over Indian subcontinent. But apart from India, okay, there are other regions as well where the monsoons are developed, but not as well developed as across India and the other parts, okay, adjoining it. And this is mostly because of, also you can say, topography, coastline modification, right? Otherwise the monsoons are not as well developed here. The best monsoons are developed across, okay, South Asia, parts of Southeast Asia, etc. Right? And yes, also across northern Australia, because there will be reversal of the winds. Okay, so when during the winter season there is the northeast winds which are prevalent over India, then there can be rainfall across northern Australia because of the shift in the ITCZ. Okay, now let's try to understand the mechanism. Okay, now first of all, understand that southwest monsoon, that is associated with, okay, the monsoon season that brings from June okay, which brings in rainfall and moisture across India, right? Now this is the condition which exists during the summer season. But to understand this, first of all we need to understand why rainfall does not happen before June. Okay, first of all we need to understand that winters mein to nahi hoti thi rainfall, and even in May when there is heavy insolation, then also is there onset of the monsoons? No. When is the onset of monsoons? Somewhere around June, right? So to understand this diagram, we'll come to this diagram. First of all, let's understand the other aspect, that is why the rainfall does not happen in the other months. Okay. Now see, during winters, very prominently, just understand this as I'm telling you. First of all, what is the type of the winds which are present here? As per the zonation that we have discussed yesterday, kal wala diagram yaad hai? इक्वेटर पे कौन सा प्रेशर बेल्ट होगा? इक्वेटर लो प्रेशर बेल्ट, सब ट्रॉपिकल हाई प्रेशर. वेरी गुड. So what is the type of the winds? These are the winds, right? So which type of winds are present here? That is northeast trades. Okay. Now the first condition that persists during this month is that is present of the northeast trade. Okay. So during winters, first of all there is presence of the northeast trades. So northeast trades are blowing in the winter season. Okay. Now these are the dry winds. These are the cold winds. These are the dry winds. So hence lack of precipitation first of all. But in certain areas, for example, when they are traversing over this region, Bay of Bengal, they can carry certain moisture, and that is why it can result into precipitation over parts of South India. For example, parts of Tamil Nadu. Very good. Okay. Otherwise, it would be almost a dry season. Mostly it would be dry. Okay. So this is the first condition, that is presence of the northeast trade. So hence, because of which we do not have the precipitation. Okay. Next, second important condition, that is the subtropical westerly jet stream. Okay. STWJ. Now subtropical westerly jet stream, it bifurcates. Okay. It bifurcates in winter because of this topography. So you can see a bifurcation here. It is bifurcated. Okay. Now it is bifurcated because of the topographical aspect, and in the winter season it is a bit south with the apparent movement of sun. So jet streams are a bit southward. Okay. So this is the southern branch of the STWJ. So this is the southern branch. STWJ is subtropical westerly jet stream. Okay. So remember two prominent jet streams. One is subtropical westerly and the other is the polar jet stream. Okay. So subtropical westerly jet stream will play a very important role with respect to the onset of the monsoons. Now see, when we talk about the jet streams, so you remember this, that this is the high pressure center and this is the low pressure center, right? So by Ballett's law, now if this is the high pressure center and if this center is present over any particular region, will there be a convergence or divergence? Divergence. Simple. So will this be a condition of stability or instability? Very good. Stability. Divergence, stability, lack of precipitation. Correct? Now see, the winds at the high pressure center, they would be descending winds, right? They are descending winds. okay, and leading to divergence. This results into stability and the lack of precipitation. Now throughout winters this condition persists because of the presence of the southern branch of the STWJ. Very important. Now you can see in this diagram, this is the southern branch of the STWJ. So which center is this? High pressure center. So because of which what happens? Because this high pressure is sustained in the winter season on India, because of which there is no rainfall. समझ में आ गया? एकदम clear है? So एक तो क्या है? Presence of northeast winds. Secondly, presence of the high pressure center associated with STWJ. तो इसको हम कैसे लिख सकते हैं? Presence of high pressure center resulting into lack of precipitation. Simple. देखो एक तो पहले समझ में आया, there is presence of the northeast trade, that is clear. So northeast trade would bring precipitation where they are onshore, on the eastern margins, right? On the western margins they will be dry winds. This is clear to us, this first aspect clear है ये एकदम. ये कहाँ से आ रही है? कॉन्टिनेंटल है ना, जब ये मॉइस्चर लेके जाएंगी तभी तो ये बारिश करेंगी. तो ये क्या हो गई? ड्राई विंड्स हो गई, नॉर्थ ईस्ट ट्रेड्स. दिस इज क्लियर टू अस और नॉट? दिस इज क्लियर everyone? This is clear or not? Right? Second, I am saying that there is presence of the southern branch of the STWJ, that is subtropical westerly jet stream. So subtropical westerly jet stream that is bifurcated. ये दो parts में bifurcated है because of Tipton plateau, right? Now what happens is this southern branch is associated with this high pressure. High pressure में क्या होता है? Stability. हाई प्रेशर में आपकी प्रेसिपिटेशन नहीं होगी. हाई प्रेशर में कैसी होंगी? डिसेंडिंग विंड्स, डाइवर्जिंग विंड्स. अब हाई प्रेशर सेंटर की वजह से क्या होगा? हाई प्रेशर सेंटर है तो बारिश होगी क्या? नहीं होगी ना, वो तो बैरियर ही है ना हाई प्रेशर सेंटर. तो इजंट इट सो? प्रेसिपिटेशन के लिए हमें लो प्रेशर सेंटर चाहिए जो कि अभी डेवलप्ड नहीं है, इतना याद रखो, ठीक है? सो हाई प्रेशर सेंटर की वजह से अभी बारिश नहीं होगी. देयर विल बी नो प्रेसिपिटेशन. दिस इज क्लियर? यस और नो? एकदम क्लियर है? So this is the second condition and the very important condition. Now what happens is during the summers you can see that it has migrated northwards. So when there is migration of the STWJ northwards, immediately that high pressure center that is also dissipated, that moves northward. Immediately there will be the onset of the monsoons. Okay, so what happens is northward migration, northwards migration of STWJ, subtropical westerly jet stream. Okay, because of which the high pressure center that is also no more existent over India. Okay, so this is very important condition first of all. Okay, now next, now ITCZ also will migrate northwards with the apparent movement of the sun. ITCZ would migrate northwards, right? Migration of the ITCZ results into monsoon trough here over India. Now what is being shown here, that is in form of the low pressure center. So यहाँ पे आपको L दिख रहा है लिखा हुआ. This is nothing else but the monsoon trough, which is the low pressure center. How this low pressure center develops is because of the northward migration of the ITCZ. So subsequently this is the monsoon trough. Monsoon trough, which is now existent over India because of the northward migration of the ITCZ. Just whatever I'm telling, वही points अभी याद करो. We'll come to these diagrams again. Okay. So this is the condition which starts to develop when there is the movement of the sun. Okay, during the summer. So even during May, there is heavy insolation. Even there can be the presence of ITCZ. But till there is northward migration of the STWJ, there will be no onset of the monsoons. ये clear हो गया एकदम? सिर्फ ITCZ के presence से नहीं कुछ होगा. Until and unless the STWJ it migrates northwards. No, after winter. Okay, but even in May, the question can be why there is no precipitation even when there is high insolation. But क्यों नहीं होती precipitation? मई में तो नहीं होती. Why there is no break of the monsoon? Onset क्यों नहीं है? Break नहीं, onset क्यों नहीं है? Because of the presence of the STWJ. जैसे ही वो shift होगी, then we will have the onset of the monsoon. Okay. Now see. Okay. Now this is the condition which exists in the summers. Now in summer, first of all, what we have learned, that is there is northward migration of STWJ. So we'll just write down, that is northward migration of STWJ. Secondly, very, very important condition that is required is, now see, Tipton region has got an elevation. Now very important role is that of the Tipton Plateau, which is associated with the Indian monsoons. Okay. Now because of elevation, what happens during the summers? Okay. When the snow would melt. Now because of the elevation, uska height hai na? When the snow would melt, then this would become a pressure of the low pressure center. ये सेंटर कैसा बन जाएगा? लो प्रेशर सेंटर, क्योंकि हैवी इंसुलेशन हो रहा है यहाँ पे और एक अल्टीट्यूड भी है यहाँ पे. सो दिस इज अ काइंड ऑफ द लोकलाइज्ड लो प्रेशर सेंटर. अदरवाइज दिस इज द एरिया, हमने जब प्रेशर बेल्ट्स पढ़े थे, सो दिस इज नॉट द रीजन ऑफ लो प्रेशर सेंटर, इजंट इट सो? यस, बट दिस इज अ डेविएशन फ्रॉम द नॉर्मल. ये डेविएशन क्यों है? बिकॉज ऑफ द एलिवेशन. सो एलिवेशन में इंसुलेशन होगा, दिस बिकम्स अ लो प्रेशर सेंटर. So this becomes a low pressure center. Very important. So this becomes a low pressure center. In the summers, due to melt of the snow. Clear हो गया एकदम? Now second condition is also developed. But very importantly, in those years when the snow will not melt properly, will this low pressure center be properly developed? No, this can happen. Okay. In the years when the low pressure develops very properly, जब low pressure अच्छा develop होगा, in those years the monsoons are very well developed. Monsoon rainfall अच्छा होगा. ठीक है? So ये second condition हो गया. Okay. Now let's see this diagram. Now this is the low pressure center which is developed. So low pressure center which is associated with the ascending air, right? So it is associated with the ascending air. And also there is a localized high pressure which is present across Mascarene Basin. So Mascarene high pressure also exists here. Now both of them will form a coupled system, rising air and this descending air. So this would form a coupled system, but this happens only during the summer with the northward migration of the STWJ. Okay, so this is the third aspect, that is the coupled system. between masculine high pressure and the Tipton low pressure. So this stream that emerges during the summer, that is referred to as the tropical easterly jet stream. Okay, so this is a localized one. This is the TEJ. So this is TEJ, that is the tropical easterly jet, which is very feeble, which is not very strong in the years when the low pressure is not properly developed. Okay, so there can be interannual variability as well. So this is the coupled system which exists. Okay, now this is the next condition. Okay, so heating of the Tipton plateau creates the TEJ. Now the next question is, what about these winds? From where they are coming? There were the northeast trades. So how come the southwest monsoonal winds? So this is very simple aspect. इसको कैसे देखना है? The ITCZ has now shifted northwards. Okay, so see what happens. So this was the convergence which was happening in the winters. So these are the northeast trade and southeast trade. So convergence. Now ITCZ has shifted a bit northwards. Now these trades on crossing the equator, okay, now in the northern hemisphere these trade winds, they are deflected towards their right. So these trades only would deflect towards right. They are nothing else but the southeast trade only, right? So now they would become the southwest trade. Deflection of the southeast trades towards right. In northern hemisphere. This is clear? Simple. So अब कौन से winds हैं over India during this season? Let's say during June. Now which winds are prevalent over India? Southwest monsoon winds. Okay. So let's recall very quickly what are the conditions now during June. First of all, सबसे पहले क्या हुआ? Northward shift of the STWJ. Very good. Second, ITCZ presence over India, creating the monsoonal trough. Very good. Third, presence of the TEJ. Very good. Fourth, presence of the southwest monsoon winds. Okay. So now these four conditions are existing over India. These are the perfect conditions which can result into the onset of the monsoons. Now see why it is very properly developed over India. Maybe if this topography was not existing, maybe this monsoon system would have not been existing altogether, right? So very important role of Tipton Plateau, very prominent role. Okay. So अब हमारे कौन से important winds है यहाँ पर? Southwest monsoonal winds. Okay. और ये किसके साथ coupled system बनाता है? Mascarene के साथ. Okay. So this is the southwest monsoon which gets coupled with this entire system. Okay. So as well as this Mascarene high pressure developed, this would fuel the southwest trade winds. So very importantly, Mascarene high pressure, okay, whenever it is further propelled, जब ये बहुत अच्छे से develop होगा, तब क्या होगा? It would further push the southwest monsoonal winds. Simple. Okay. Now let's see all these diagrams. Are we able to correlate? Okay. So this diagram is clear to us now. This is the northward migration. This is clear to us, right? So this is now the summer condition with the further migration of ITCZ, which is now the NITCZ, okay, North ITCZ, okay. And here, because the ITCZ was southward, so there was presence of the northeast trade. So this is the summer condition, and this is the winter condition. Very simple. So presence of the southwest trades, simple, and this was the winter condition. So that is the reason why there is less winter rainfall, no winter rainfall, which is scattered, which is present only across certain regions. Simple. Now are we clear on this? Why there is no monsoonal rainfall, less monsoonal rainfall in the winters? We are clear on this, right? Now next. Okay. So this is the mascarene high and the monsoonal trough. So they become the coupled system. Okay. So this is the coupled system. Okay. So now let's draw everything on this diagram. So first of all, there is this coupled system. This is the coupled system. Okay. Presence of the southwest monsoon winds. Now when the STWJ has migrated northwards, there is sudden onset. Onset किसको बोलते हैं? एकदम से monsoon start हो गया. That is the term monsoon onset. Now when the monsoon onset would happen, it would start from south, simple सी बात है. When it would start from here, then because of topography itself, the only reason is topography. These monsoon winds, they are divided into two branches. Okay. So one branch is this and another branch is this. One branch is the Arabian Sea branch and another branch is the Bay of Bengal branch. Okay. So this is the Bay of Bengal branch and this is the Arabian Sea branch. Now very importantly, we must understand, even when the onset happens, but do all the locations in India receive the same amount of rainfall? No, right? So we must learn why that happens. Okay. So first of all, let's take this map. Okay. So here what happens is, it is now divided into two branches. Okay. Okay. Now this is the Arabian Sea branch. And this is the Bay of Bengal branch. I have already explained you the factors, so you can give this as a heading as the spatial distribution of rainfall over India. What does spatial distribution of rainfall means? That how the rainfall is spatially distributed over any region. So spatial distribution of precipitation can be across world also. This is across India, simple. So this is the first branch. Now see, first of all, across the Western Ghats, there is an orographic barrier, right? There are mountain ranges here. So because of this barrier itself, there would be precipitation here. So this is the first region to receive rainfall, apart from the island regions. Island regions would also receive, but apart from that, first of all, this coastal area, okay, that is around Kerala would receive the precipitation. Why? Because of the presence of the orographic barrier. And then subsequently, this entire region would witness rainfall because of presence of the western slopes of the Western Ghats. Simple? Okay. So here, first of all, there would be the rainfall across the western slopes of Western Ghats. Now very importantly, because there is the early onset, सबसे पहले यहीं से onset हुआ, right? and it would continue because there is the orographic barrier. So we receive very heavy precipitation here. So precipitation can be around 250, can be even 300 centimeters. Okay, so you can just mention those figures as well. Sometimes they give you this data in the prelims, that is this amount of precipitation happens across this region. Which type of region is this? ऐसे question पूछते हैं ना. So this is the region which is having the evergreen vegetation. Okay, and this is the region having around 250, even 300 centimeters rainfall, very heavy rainfall. Okay, next region, that is, now these winds, they are blowing parallel to the coast, right? There is no barrier here, so they are mostly blowing parallel. But again here there is orographic barrier across northeast region. Again there is orographic barrier or not? Yes. So because of which here again there is rainfall. So because of orographic barrier. So again here there is very heavy precipitation, around 200, 250, 300 like that. Okay, so heavy precipitation, very heavy rainfall. Now the winds, because of topographical barrier only, they are deflected towards their west. Now as they are deflected, they would result into rainfall across the other parts of India. Okay, but now this branch, it was traveling here also, right? This Arabian Sea branch, it was also traveling here. Okay, because of the topography here, till here there is the orographic barrier. बाकी तो यहाँ से pass करेगी ना, right? But now is there any orographic barrier here? No. The Aravallis are oriented parallel to this branch. So because of the parallel orientation of the Aravallis, there will be almost no precipitation. There can be some bit of precipitation in the southern slopes of the Aravallis, but not anywhere in Rajasthan. So why Rajasthan is drier? Because of this perspective only. Okay, because of the parallel orientation of the Aravallis to the Arabian Sea branch of the southwest monsoon. Simple, right? This is clear. Now these winds, they would go and hit which particular, first of all, which particular mountain ranges? Shivaliks, right? अब शिवालिक्स में हिट करेंगे कि नहीं? अब शिवालिक्स में भी there will also be an orographic rainfall. Okay, so again there will be orographic rainfall here. So there will be heavy precipitation here also across the foothills of the Shivaliks, and as we move towards the greater Himalayan region, okay, ascending air, remember that aspect, ascending air होगा ना, ये इसको समझ लेते हैं, बहुत important बात है. So like this, there is ascending air. Okay, so when we go from south to north, from Shivaliks toward middle Himalayas toward great Himalayas, so there will be precipitation. Okay, but this is which lapse rate? Which lapse rate? Adiabatic lapse rate. Very good, excellent, right? कल का डिस्कशन थोड़ा थोड़ा याद आ रहा है कि नहीं? एकदम, अरे ये कौन सी बात बोल दी, कुछ याद आ रहा है? Adiabatic lapse rate याद आ गया? ठीक है, ascending air, there will be rainfall. So here that would be the windward side. But now as we move towards the trans Himalayas, these are the descending parcel of air, right? So hence they are dry, they are leeward. So will there be rainfall? No. Okay, so hence these are the trans Himalayas which are drier. So Shivaliks, middle Himalayas, greater Himalayas, and then there is the dry descending air. So this one particular pocket, that is the trans Himalayas, can have as less as precipitation as 20-25 centimeters per annum. इतना कम precipitation हो सकता है, ठीक है? So which are the trans Himalayas? What are the ranges of trans Himalayas? Very good, काराकोरम, लद्दाख, ज़ंस्कर, very good, है ना? तो ये सब में precipitation एकदम नहीं होगा. Precipitation जो होगा, that is in form of snowfall. Okay, that is in winter season. So this is one pocket which will have very less precipitation apart from Rajasthan. Okay, interiors of Rajasthan and parts of Gujarat. Why? Because the orientation is parallel to Aravallis. And then you can see that across the western slopes of Western Ghats there will be heavy precipitation. same phenomena, right? But on the eastern slopes, again there will be the leeward impact, right? There will be the leeward impact. Now because of which the plateau interiors are drier. So this is the third pocket, this is the first pocket, this is the second pocket, this is the third pocket. So third pocket would be the plateau interiors. Second was Rajasthan and Gujarat, parts of Gujarat. Okay. Plateau interiors encompassing parts of Maharashtra, parts of Andhra, parts of Telangana, okay, even parts of Tamil Nadu interiors. So here there will be less precipitation. Okay. Now this is what is happening in the summer season. Okay. Most of this area would get the precipitation from the retreating monsoons. When the winds, when the ITCZ will start shifting southward, then again there will be the northeast winds which would start impacting India. अब जैसे northeast winds होंगी, ठीक है? So it would bring moisture from here, resulting into precipitation here. So यहाँ पर आपका जो है winter precipitation would be more prominent. Okay, but as you move from east to west, generally there will be a decline in the amount of precipitation. So this is clear spatial distribution of precipitation. Now if you are clear on spatial distribution of precipitation, then you should be clear about the vegetation, associated vegetation also, right? So for example, when we talk about plateau interiors, what type of the vegetation will be prominent here? कैसी vegetation होगी? Okay, deciduous and नहीं, precipitation नहीं. I'm asking about vegetation. Vegetation कैसा होगा? Dry thorny, dry deciduous, right? Dry deciduous, correct. ठीक है? So these are the things which are to be done in interrelationship. Okay. Now see, this is a very comprehensive diagram which explains all the phenomena associated with the monsoons. So low pressure, okay, masculine high coupled system, ITCZ, this is ITCZ. Just take a look over it for 30 seconds. इसको register कर लो एकदम. And very important aspect that I am telling here, I will be explaining in the coming slides. बहुत ध्यान से देखो, this is the masculine high pressure, right? Masculine high pressure is also forming a coupled system here. Please pay attention very carefully. You would understand why there are interannual variations in monsoons over India. Okay. So here this masculine high forms a coupled system with a low pressure center here. Because of strengthening of this coupled system, what would happen? The monsoons will be further enhanced. If this coupled system is weakly developed, then what would happen? Then the masculine high is not properly developed and there would be a weaker rainfall. Just remember this. I will be explaining this, okay, with the help of Walker cell, but just remember this, that this masculine high, okay, so masculine high and low pressure center of coast of Australia, they would form a coupled system, and this Walker cell would impact the monsoons over India. Okay, just remember this. ठीक है, सिर्फ ये याद कर लो. अभी Walker cell I would explain, then you would understand this. So Indian monsoons and the associated factors, they are clear to us. एकदम clear हो गया? ठीक है. Now apart from this, there is another phenomena, that are the western disturbances. Now STWJ, now again during the winters, it would re-establish here, right? Subtropical westerly jet stream, they re-establish now over India in the winters, yes or no? Yes. Now see, subtropical westerly jet stream, they re-establish over India during winters. So कौन सा वाला आपका मैप अब suitable होगा? This one, right? Now this is the winter condition. Now subtropical jet stream has re-established over India. This is clear to us, right? Now in that condition what can happen is there can be extratropical cyclones which emerge around the Mediterranean region. Now this subtropical westerly jet stream can carry those extratropical cyclones towards India. But now because of the existing temperature conditions, this can result into snowfall. Okay, so this is called as the western disturbance, which results into precipitation over parts of northwest India and can also result into snowfall over parts of the western Himalayas. So that is called as the western disturbance. So what is western disturbance? It is an extratropical cyclone originating in the Mediterranean region that brings a sudden winter rainfall in the northwestern parts of Indian subcontinent. So कल एक PYQ पढ़ा था हमने जहाँ लिखा था that the winter rainfall is because of westerly. Now is it clear? It is because of westerly or not? Yes, because this is subtropical westerly jet stream. Okay, so simple, clear हो गया अभी एकदम. So this is the third type of rainfall, but intermittent one, which can happen because of the subtropical westerly jet stream, okay, which carries the extratropical cyclones. So that is called as the western disturbance. Now very importantly, इसको बहुत अच्छे से समझना है because climate change के साथ ये relatable हो रहा है. Now what is happening is this in a normal year would result into heavy snowfall कहाँ पर? Over India कहाँ होगा heavy snowfall? नॉर्थ इंडिया में तो नहीं होता है यार स्नोफॉल. हो जाए तो मज़ा ही आ जाए, है ना. घूमने के लिए हम शिमला मनाली नहीं जाएंगे फिर. नॉर्थ वेस्ट हिमालयस, हाँ, कश्मीर हो गया, उत्तराखंड हो गया, है ना. उत्तराखंड में हो जाएगा, हिमाचल में हो जाएगा, है ना. अच्छा, किसी साल जैसे कि लास्ट ईयर एक न्यूज़ आ रही थी, आपने पढ़ा था, देयर वाज अ न्यूज़ दैट टिल जनवरी फरवरी देयर वाज नो स्नोफॉल अक्रॉस जम्मू कश्मीर. ये पढ़ा था न्यूज़ में. लास्ट ईयर था ना, आई थिंक लास्ट ईयर था या लास्ट टू लास्ट ईयर था. लास्ट ईयर था, है ना. बहुत लोगों का घूमने का प्लान कैंसिल हुआ इसलिए इतनी तेज आवाज आई, है ना. तो लास्ट ईयर क्यों हुआ ऐसा कि फरवरी तक स्नोफॉल नहीं हुआ? इट मस्ट हैव गॉट समथिंग टू डू विद द वेस्टर्न डिस्टर्बेंस, राइट. नाउ सी व्हाट इज हैपनिंग इज बिकॉज ऑफ क्लाइमेट चेंज, बिकॉज ऑफ ग्लोबल वार्मिंग, द जेट स्ट्रीम्स आर शिफ्टिंग अ बिट नॉर्थवर्ड्स. ओके, सो बिकॉज ऑफ क्लाइमेट चेंज, let's take this light. So generally what is happening is there is an observation, that is the jet streams, they are shifting northwards. So this STWJ, that is also shifting a bit northwards. This is kind of an inter-annual variability that we are seeing. In some years we are witnessing this phenomena, okay, that is the northward shift of the jet streams is being witnessed. In some years it is very prominent now, right. So this is what happened in the last year. Now with the northward shift, what would happen? These cyclones which were being carried towards parts of India, now they are being carried towards parts of the Tipton region. So heavy snowfall would happen where? Across Tipton region. Heavy snowfall. And what happens is, when this happens, so in that particular year, okay, snow does not melt properly during the summer season. Snow भी melt नहीं होता. अब जब snow melt नहीं होता तब क्या होता है? वो low pressure center is weakly developed, right? So in this particular year, the low pressure is weakly developed due to heavy snowfall during winters. When this low pressure is not properly developed, now my question is, in that year will the monsoons be enhanced or weakened? Simple, क्योंकि coupled system ही properly नहीं form हुआ. समझ में आ गया एकदम. तो अब क्या होगा? Monsoons are weakened. No, this is one reason. Very good question, but this is only one factor. There are so many factors that we discussed. हमने तो और भी factors पढ़े ना. This is one factor which can weaken the monsoon. But there are other factors also which we will learn today. But ये एक factor है ऐसा, ठीक है? और भी तो factor होंगे ना, क्योंकि हमने और भी factors पढ़े जो responsible है monsoons के लिए. This is only one factor. Okay? There can be other factors as well. नहीं, टोटल 3 नहीं है, टोटल तो बहुत सारे हैं, अभी तो रिसर्च चल रही है उसके ऊपर. मतलब सी देर आर सो मेनी कनेक्शंस विच आर नॉट गेटिंग डेवलप्ड बिकॉज ऑफ ग्लोबल वार्मिंग. सो वी विल स्टडी विच इज रिक्वायर्ड फॉर अवर सिलेबस एंड एज मेनी क्वेश्चंस विच कैन बी कमिंग फ्रॉम दिस सिलेबस पार्ट. बहुत सारी अभी चीज़ें रिसर्च में है जिसमें हमें नहीं जाना है. बड़ा कम्प्लेक्स सिस्टम है इंडियन मानसून्स, राइट? सो वी विल बी कंसंट्रेटिंग ओनली टू दी टॉपिक्स रिलेवेंट टू अवर सिलेबस. सो दिस इज क्लियर और नॉट? यस. So low pressure अगर weakly developed हुआ तो snowfall कम होगा. Okay, so this is what happened last year. Okay, last year why there was less snowfall, right? So this is one reason. So I hope now this is clear to you. Okay, now one question: seasonal reversal of wind is a typical characteristic of simple monsoons. इस टाइप के क्वेश्चन भी पूछ लेते हैं यार. देखो इतने ब्राउनी क्वेश्चंस है ना, तो इसमें जल्दीबाजी नहीं करनी, बस ध्यान देके क्वेश्चन कर लेना है. अब ये नहीं बोलना मैडम अब नहीं आते ऐसे क्वेश्चन. इस साल तो आए थे कि नहीं आए थे? आते हैं. चलो, दैट वाज अबाउट मॉनसून्स. नाउ आई होप दिस फिनोमेना इज क्लियर टू यू, राइट? चलो, नेक्स्ट यू कैन राइट डाउन एयर masses. What are air masses and some important phenomena which are relevant for our syllabus? Let's understand that. Now what is air mass? Air mass is a large body of air which is having generally uniform temperature and humidity conditions. So this is a large air parcel which is having uniformity in terms of conditions of temperature and humidity. ठीक है, टेम्परेचर कांस्टेंट है एक लार्ज एयर पार्सल में, so that is an air mass. Simple. The area over which the air mass originates is what provides it the characteristics of the air mass. Now the air mass can originate over the continental areas. Okay, it can also originate over the maritime areas. Very good. So wherever it is originating, it would take its characteristic. So for example, the air mass is originating over the open waters, so it would definitely have more moisture, right? Whereas when it is originating over the dry continental areas, okay, so then it would be more drier in nature, right? So it will take the characteristics of the place from where it is originating. So for example, when we take this globe picture, you can see large pockets of these air, okay, which are the air masses which are denoted by, okay, certain symbols like MT, MP, etc. Let's learn about this. Okay, so there are different air masses. So first of all, understand the denotion. First of all, M and C, they are important because this is maritime and this is continental. So this is the first differentiation on the basis of where it will originate. तो maritime air mass कौन सा हो गया? जो maritime उसका origination हो गया, and continental it is originating from the continental areas, right? Then it can be further designated as P, which would denote polar, or T, which is tropical. Okay, so this is the first level of segregation on the basis of which we have these air masses. Okay, now MT, what would it mean? M means maritime and T means tropical. So maritime, but in which zone, which area? Tropical area, MT. CT means continental, tropical. M, maritime, can also be in the polar area, so maritime, polar, and CP, continental, polar. Similarly, continental, Arctic. way above northward. Okay, so continental Arctic हो गया. What will be the characteristics of the maritime tropical? It would be moist because it is originating in the tropical area, so it would be warmer. So warm, moist. Okay, continental tropical would also be warm, but because it is originating from the continent's interior, so it will be drier. Okay, similarly the other characteristics, maritime polar would be cool but moist, continental polar would be cold and dry, and continental Arctic would be very cold and dry. Okay, so the locations that I have already told to you. Now see on this map particularly these air masses. Yes. Continental tropical means it is originating on the continents, okay, in the interiors, continents, in the tropical location. Okay, for example CT देखो आप, continental tropical. Okay, similarly maritime tropical, tropical location में originate कर रहा है, but कहाँ, maritime में या फिर continental में. Clear हो गया? पोलर में भी हो सकता है, ट्रॉपिकल में भी हो सकता है. ठीक है, अब मैरीटाइम पोलर में भी हो सकता है ना. नाउ सी, फॉर अस वेरी इंपॉर्टेंटली वन वेरी बेसिक एस्पेक्ट इज दैट ऑल एयर मासेस आर नॉट वेरी इंपॉर्टेंट फॉर अस. हमें सारे एयर मासेस नहीं याद करने. ठीक है, एयर मासेस पे एक डायरेक्ट क्वेश्चन मेंस में पूछा हुआ एक बार. आई थिंक इन 2016 दे हैड आस्क्ड अ डायरेक्ट क्वेश्चन ऑन एयर मासेस. व्हाट आर द एयर मासेस, लाइक दैट दे हैड आस्क्ड अ क्वेश्चन आल्सो. अच्छा देखो, there are multiple air masses which we are seeing here. So maritime polar, this is clear. Continental polar, this is clear. Continental and polar location. So this is the polar location, okay, and this is the tropical location. So tropical empty, maritime tropical, continental tropical, maritime tropical, continental tropical, right. Now all of the air masses are not very important. Southern वाले तो important नहीं है, because see where we have to study the climatic phenomena, where there is an impact on the population as well. So because there is very less population here, so we are not much interested about these air masses and their interactions, but they are happening here also, right. We are more interested in these areas. Why? Because if you remember the diagram that is with respect to winds and the pressure systems, so what we had studied, there is a contrast of the air masses here, right. So the contrast of air masses, because these tropical air masses, this would be warm in nature, and these air masses, this would be cold in nature. So this interaction boundary is very interesting, where there is an interaction of the warm and the cold air masses. So that is the boundary associated with the fronts. Understood? So here this is the warm air masses. So this interaction happens in the following manner, that is the cold polar air mass and the warm tropical air mass. So they interact, resulting into fronts development. So here we see the development of the temperate cyclones as well. Okay. Now very importantly, when such type of interactions are happening, it is best developed across North America. So hence it influences the weather of North America very profoundly. North America का जो आपका जो climatic interactions है, they are definitely impacted because of the presence of the contrasting air masses. Let's take some example. So first of all, you can see this maritime polar air mass. Okay, and here there is orographic barrier on the western coast of North America, which is that. So now because there is an orographic barrier, so this is kind of the interaction like this, right. So there is presence of the orographic barrier, and this is the maritime polar air mass. So as the maritime polar air mass that would ascend on the western slopes of, okay, these mountain ranges, what would happen, there would be heavy precipitation, whereas on the eastern parts, will there be precipitation? No, these are the descending air. Okay, so because of which, okay, they are the warm winds स्नो ईटर विंड्स जिसको बोलते हैं. क्यों? बिकॉज दे आर द डिसेंडिंग ड्राई विंड्स. सो दिस इज वन एग्जाम्पल ऑफ MP, that is maritime polar air mass. We can write down this example, very important. Okay, that is precipitation here, and this is the dry descending air. Dry descending air. Okay, now second interaction which is very important. So this is this air mass, okay, which impacts the western slopes. Now there is another air mass which is very important here, that is the continental polar air mass. So what will be the characteristics of this air mass? Continental polar का क्या characteristic होगा? कैसा होगा ये? ड्राई होगा या फिर ड्राई होगा? वेरी गुड. ड्राई और कोल्ड होगा कि वार्म होगा? कोल्ड. वेरी गुड. ड्राई कोल्ड एयर मास. So this is that air parcel which is coming from the northern Canada. Now when it would move over this Great Lakes region, now imagine what type of interaction would happen. Now over the Great Lakes region, okay, so this air parcel which would be existing here, that is over the Great Lake region, that would be a warmer one or the more cold one as we compare it with CP? वार्मर होगा, राइट? सिंपल सी बात है. नाउ वार्म कंडीशंस आर एग्जिस्टिंग हियर, ओके, एंड देयर इज लॉट ऑफ मॉइस्चर बिकॉज इट इज मूविंग ओवर द ग्रेट लेक्स रीजन. नाउ एज इट मूव्स हियर, सो ऊपर कौन सा है? कोल्ड और नीचे वार्म. ये कौन सा कंडीशन हो गया? स्टेबिलिटी और इंस्टेबिलिटी? इंस्टेबिलिटी. वेरी गुड. ओके, सो इट विल पिक द मॉइस्चर फ्रॉम दिस रीजन, बट बिकॉज इट इज वेरी कोल्ड, सो कंडेंसेशन विल हैपन इन फॉर्म ऑफ स्नोफॉल. So it can result into snowfall here over the Great Lakes region. So what would happen? There would be snowfall. Rain हो सकता है, but because it is very cold, बहुत cold है ना वो air mass, yes, snowfall हो जाएगा. ठीक है. अच्छा, ये जो है यहाँ पर क्या हो जाएगा? snowfall हो जाएगा. ठीक है. So this is called as lake effect. So this, when it passes over the Great Lakes region, it can pick up moisture. So depending upon the temperature, there can be different types of the condensation, right? So this will be in form of the snowfall. So this snowfall over the Great Lakes region because of the continental polar cold dry air mass is called as the lake effect. Simple. Okay. So if there is such any question, you can attempt it now. So there are other interactions also. I have given you certain examples. I hope this is clear to you, right? Now next, write down Walker circulation. Yes, Atish, it is cold and dry. Very good. Okay, so Walker circulation. Now when we talk about the circulation which is happening because of the permanent winds, what type of circulation that is? That is जो हमारी permanent winds हैं, on the basis of which we are having circulation, right? Atmospheric circulation है. वो किस type का circulation है? What is the term? हमारा जो Hadley cell है, तो ये जो सर्कुलेशन है कौन सा सर्कुलेशन होगा? हाँ, जो आपका मैंने परमानेंट प्रेशर बेल्ट्स बताए हैं एंड विंड्स हैं, व्हाट टाइप ऑफ सर्कुलेशन दैट इज? गिव मी वन टर्म. व्हाट टाइप ऑफ सर्कुलेशन दैट इज? हेडले. हाँ, तो वो क्या टाइप का सर्कुलेशन है? ध्यान से सोचो, विच टाइप ऑफ सर्कुलेशन दैट इज? हाउ डू वी रेफर इट टू एस? कौन सा सर्कुलेशन है वो? वो टर्म, आई वॉन्ट दैट टर्म. व्हाट इज दैट सर्कुलेशन? क्या है वो सर्कुलेशन? नहीं, वॉकर सेल नहीं. वॉकर सेल तो अभी बताएंगे. सोचो, एक थोड़ा 15 सेकेंड और लो. अरे ये क्या बात है, मैं कोई प्री का पेपर थोड़ी ले रही हूँ. ऑप्शन ए, ऑप्शन बी. अरे कौन सा सर्कुलेशन होता है यार, सिंपल. व्हाट टाइप ऑफ सर्कुलेशन दैट इज, कैसे सर्कुलेशन हो रहा है? हाँ नहीं नहीं, मतलब सर्कुलेशन क्या बोलते हैं, व्हाट इज दैट मॉडल कॉल्ड एज? अब बोलो, अब तो बोल दो, व्हाट इज दैट मॉडल? ट्राइसेल्युलर मॉडल, मेरिडोनियल, राइट? मेरिडोनियल सर्कुलेशन है. नाउ दिस इज क्लियर, अक्रॉस मेरिडोनियल सर्कुलेशन. ठीक है, अब तो क्लियर हो गया. मेरिडोनियल, because meridional circulation is happening, isn't it so, across the 3 cells? So meridional circulation, simple. Now see, there is another circulation which is also happening east west, which results into the Walker cell. Okay, so what is Walker cell? Apart from the north south circulations previously discussed, there are other east west circulation pattern also, but these east west circulations also impact the weather conditions. These east-west circulation which are developed very prominently across Pacific, okay, and also the branch goes towards the Indian Ocean, this is called as the Walker cell. But here what will be the circulation? That the circulation would be east-west circulation. Okay. So this longitudinal east-west circulation across the equatorial Pacific, but which also extends towards Indian Ocean, that is known as the Walker circulation or the Walker cell, simple. Okay, this is the Walker circulation or the Walker cell. Okay. This is, that is what I am telling you, this is apart from those circulation, that is the tricellular meridional circulation. आप समझ में आ गया? This is not that, this is a separate one. This is a separate circulation, east-west circulation. Okay. Now let's see what happens in this. Now first of all, just remember this Walker circulation, that is itself called as ENSO. ENSO एक ही बात है, ENSO Walker circulation एक ही बात है. उसके 3 phases होते हैं. One is a normal year. So what I am trying to tell you is, so there is a so this is your tricellular model, meridional circulation. But apart from this, there is also an east-west circulation. Okay, so there is an east-west circulation. This east-west circulation that is called as the Walker cell. इसमें कैसा सर्कुलेशन था? So what was the type of circulation here? North south? In this circulation was north south not? Yes. So this is an east west circulation. Now see, when we talk about the trade winds, right? So what is the direction? I am explaining you this Walker cell. Okay. So when we talk about Walker cell, this is itself the phenomena of ENSO. Okay, El Nino Southern Oscillation, which has the 3 phases. One is the normal phase, neutral phase. Another one is El Nino. And another one is La Nina. Okay, so these are the 3 phases, simple. ENSO, El Nino Southern Oscillation. Okay, now see, this is the direction of the trades, right? Now in a normal year, what would happen is, these trade winds, they would also, okay, impact the water surface over which they are blowing. So hence they would also carry water along with them in which direction? From east towards west. So this would be the normal direction in a normal year. So what would happen? That this warm water this would start piling up here. So this is the warm water which would start piling here. Across the Western Pacific. Okay, so there is piling up of the warm water here. Now see, because of this piling up of the warm water, is there a temperature gradient which is created between east and west waters? Yes, there is a temperature gradient which is created. So when there is a temperature gradient which is created, this would also impact the pressure. So this would become the center of the low pressure, high temperature and low pressure. So now this becomes low pressure, and because the warm water that is being taken away from eastern oceans and now it is being piled up across the western ocean. So here there is relatively lower temperature. Lower temperature means high pressure center. So there is a pressure gradient also which emerges. Now because this pressure gradient emerges, so this would be associated with the rising warm air. Okay, and here it would be associated with the subsiding air. Okay, this is a high pressure center. So subsidence. Now this east-west circulation in a normal year would be referred to as the neutral year. This is the Walker cell because it is the east-west circulation, right? So this is a normal neutral year. Okay, so this type of circulation it starts. But now because the water, ऐसे लग रहा है ना यहाँ से पानी जो है यहाँ निकल के यहाँ pile up हो रहा है, right? So here what would happen? The water from beneath would come upwards and would try to take place, okay, of the water which is being evacuated. It would seem that water is being evacuated और यहाँ पानी जो है beneath से आकर के इसका place लेगा, right? So this itself is called as the upwelling. And here there would be sinking, so this would be downwelling. So ये दोनों तरीके के circulation को maintain कर रहा है, ठीक है? Now this is a neutral year. But in certain years, because of not so well known reasons, the trade winds can weaken. Okay, so in next year, let's say the trade winds weaken. So if this trade winds weaken, so this east-west circulation that can also reverse. Okay, because now the trade winds, they are not very strong this year. So this piling up of water would not happen, right? So warm water, and there can be years when they can also see reversals also. So in that condition, okay, it would seem that the warm water is piling here. So what would happen? The reverse conditions would exist now. Okay, so this would become the low pressure center. So this would become the low pressure center. एक ही diagram में आप दोनों दिखा सकते हो. Okay, rising air and subsiding air. So now this becomes the high pressure center, okay, because of the presence of the relatively colder water. So this is the condition for El Nino. But on the other hand, if the trade winds are strengthened, then what would happen? This low pressure center, this would be enhanced. जो हमारा normal phase था Walker cell का, वो और enhance हो जाएगा. It would be strengthened. Then what can happen? This would lead to extremely low pressure condition and very heavy rainfall here. So there can be flooding type of conditions also here. That is itself what is called as the La Nina. This is La Nina. Okay, this is El Nino. So what is La Nina? La Nina is an enhanced Walker cell, whereas El Nino is a suppressed Walker cell. Right? This is clear to us. अब ये तो याद ही रखना पड़ेगा, इसमें तो क्या ही कर सकते हैं. एल नीनो मीन्स सप्रेस्ड वॉकर सेल, अगर ये भी याद रह गया तो ला नीना तो उसका रिवर्स ही हो गया ना, राइट. नाउ in the La Nina years there will be very heavy precipitation off the coast of Australia, right, very heavy precipitation here, and off the coast of Peru dry conditions, extremely dry conditions, right, but which are favorable here because a lot of fisheries takes place here, so which is favorable for this region because upwelling is very strong, right. But in the El Nino year the reverse can happen. Sometimes we hear in news that there are bushfires across Australia. They are associated with the El Nino, right. Now see, this is a Walker cell which is east-west in circulation, and this is happening in Pacific. But this can also couple with the Indian Ocean. And if it couples with the Indian Ocean system, so what can happen? It can impact the monsoons, right. So any atmospheric circulation which is happening in some other part of the world, which impacts the atmospheric circulations, the weather phenomena across any other part of the world, that is called as a teleconnection. Okay, so that is called as a teleconnection. Right, so these are called as the teleconnections. Hello, आवाज आ रही है? हाँ, आवाज आ रही है, ठीक है. So this is a teleconnection. Okay, so we have understood these conditions. Let's go back to that particular diagram that we had seen in context of the Indian monsoons. Now see, in this particular map, now this is the low pressure center. Let's take the three cases. अब आपको याद रहेगा इंडियन मॉनसून्स पे क्या इम्पैक्ट होगा. नॉर्मल ईयर, El Nino and La Nina. Now in a normal year, this low pressure center, this is developed, right. So normal impact on the Walker cell. This is the masculine high pressure, right. But in the El Nino year, this low pressure is poorly developed. Trade winds are weak. So what would be the impact on this center? The coupled system, that is not formed, right. So hence a negative impact on the Indian monsoons. But in La Nina year, will this coupled system be further strengthened? Yes. So hence it would further intensify this masculine high, resulting into heavier monsoons. So La Nina results into heavier monsoons. But you must always draw this diagram in front of your notes, ताकि आपको याद रहे कि ऐसा क्यों हो रहा है. Okay, so we can always mention this, that in the La Nina year, okay, so this masculine high, मतलब डिपेंड करता है, ऐसा नहीं है कि कोई पर्टिकुलर मंथ है, कोई पर्टिकुलर ईयर है. Okay, so it can be variable. Now see, also very importantly, these are more or less the permanent systems. These systems in which year La Nina would happen. Okay, now the months are also shifting. For example, with respect to cyclones, there was always an associated months, because when we talk about cyclones, for example, तो कौन से months में आपके form होते थे better? Which months? Late summer. Okay, because it is having higher specific heat, right? But now it is happening even in summers. So that is the deviation we are witnessing now because of climate change. I would not say this is associated with only a particular month or a particular time period, because now it is becoming so deviated. Okay, तो उसको आप किसी particular time period के साथ मत associate करो, right? नहीं, आपका ये तो कब डेवलप हुआ, मैंने अभी आपको बताया ना, ये कब आपका डेवलप हुआ, मॉनसून्स व्हेन इट इज प्रॉपर्ली डेवलप्ड आफ्टर जून, राइट. सो ड्यूरिंग दैट मंथ्स ओनली यू कैन से दिस एस्पेक्ट. ओके, बट कोई ईयर के साथ एसोसिएट मत करना, ठीक है. अच्छा, मैस्करीन हाई प्रेशर दैट इज इनहांस्ड. So heavy rainfall over India. So in La Nina we can always make a table, that is in El Nino years the rainfall that is suppressed, during La Nina it is enhanced. just make the table. I'll be explaining it to you. During positive IOD, it is again enhanced, and during negative IOD, it is suppressed. Okay, so this is clear to us. ये coupled system clear हो गया, right? So now this is what happens. This is the normal year. Okay, piling above the warm water, which I have already explained it to you. Okay, so these are the normal conditions. This is the Walker circulation. But during the El Nino event, okay, this is the condition, and La Nina event. So I hope this is clear to you, right? Next, IOD, okay, Indian Ocean Dipole. Indian Ocean Dipole. So you can also write about teleconnections. Just one point. So atmospheric phenomena which are occurring in a particular region impacts, okay, the weather conditions across other regions of world. Like El Nino, La Nina, IOD, etc. Having an impact on the Indian monsoons. Okay. So these are examples of the teleconnections. So during a La Nina year, how would be the agricultural output across India? Yes, very good. आप समझा, इसलिए एमसीक्यू भी थोड़ा सा हमारे गड़बड़ हो जाते हैं. During a La Nina year, we will have a higher monsoon, which is correct. But across certain parts, there can be very heavy rainfall also, so which can also impact the agricultural output, right? हाँ, तब तो और हैवी होगा, राइट? Yes, but there can be flooding condition also, right? दोनों हो सकते हैं, right? But during a El Nino year, generally the monsoonal rainfall is suppressed. Okay, so during an El Nino condition, it is generally suppressed. But in certain years, even when there is El Nino, the impact can be lessened. Now that is because of IOD. Okay, so what I am saying is, now see, this is the case scenario which I am saying, that during La Nina, okay, there can be heavy rainfall, and when we talk about agriculture, so yes, agriculture will be impacted because of heavy monsoons, but the other case scenario, parts can receive heavy rainfall and flooding situation as well. Now when we talk about El Nino, so in case of El Nino, it will be suppressed. the rainfall would be suppressed, right? This is the general observation. So dry conditions would persist, less than average rainfall. But there can be certain other conditions when even in El Nino we can have normal rainfall. In a particular year, if El Nino is existing, the conditions of El Nino are existing, but still there can be another phenomena which is called as Indian Ocean Dipole. Then what can happen? Then the impact of El Nino would reduce. Okay, so if it is coupled with Indian Ocean Dipole. So it can result into normal rainfall. So let's learn this. So Indian Ocean Dipole is another coupled system. Okay. So what is Indian Ocean Dipole? Indian Ocean Dipole is also referred to as IOD, okay, which is defined by difference in sea surface temperature between the areas or the poles. So that is why they term dipole. Okay, across the western pole in the Arabian Sea. Okay, so there are two poles. One pole is across the western Indian Ocean and another pole is across the eastern Indian Ocean. So because there are two poles, so that is why the term dipole. Okay, so western pole in the Arabian Sea, western Indian Ocean, and eastern pole in the eastern Indian Ocean, south of Indonesia. Okay, now because this pole exists, okay, across the Indian Ocean, hence the name Indian Ocean Dipole. That's it. Now Indian Ocean Dipole develops more prominently in the equatorial region, okay, from April to May, peaking somewhere in October. Okay, so this is the dipole which can again have different phases. Okay, so there can be different phases. Of IOD, right? So Indian Ocean Dipole can have two phases. So first phase can be a positive IOD and another can be negative IOD. So what is positive IOD? Positive IOD is when this coupled system is formed in such a manner that the sea surface temperatures of the western Indian Ocean, they are higher as compared to the eastern Indian Ocean. So here the temperatures are higher, okay, as compared to the temperatures here. So this is warmer and this is cooler. Okay, so what type of coupled system it would form? That is warmer waters, rising air, okay, ascending air, and here because it is cooler, so descending air. So this type of coupled system can form. When this type of condition forms, that is in the western Indian Ocean, the temperatures are warmer as compared to the eastern Indian Ocean. That is called as the positive IOD condition. Okay, what it is? It is the positive phase of IOD. Okay, so this is called as the positive phase. Okay, so rising air, sinking air. So across this region, what type of atmospheric phenomena will be witnessed? यहाँ क्या होगा? राइजिंग एयर, असेंडिंग एयर, लो प्रेशर सेंटर. सो क्या होगा यहाँ पे? सिंपल, रेनफॉल, फ्लडिंग सिचुएशन, राइट. सो व्हेन, लेट्स एज्यूम दिस ईयर, लेट्स कीप अपार्ट एल नीनो ला नीना, उसको अलग रखते हैं, सिर्फ आईओडी है एंड पॉजिटिव आईओडी है. सो देयर कैन बी फ्लडिंग सिचुएशन अक्रॉस द वेस्टर्न पार्ट्स ऑफ इंडिया. ओके, सो लेट्स एज्यूम द फर्स्ट कंडीशन, दैट इज there is a positive IOD condition. So heavy rainfall and also accompanied floods, especially across western coastal region. Ascending air, positive IOD. This is the positive IOD phase. Positive IOD phase. No, this is a positive IOD condition. Positive IOD phase. Okay. And secondly, very importantly, आपको मैंने कंडीशन बताया पॉजिटिव आईओडी में क्या होगा. ये वार्मर वाटर्स है, यहाँ पे कूलर वाटर्स है. अब बहुत ध्यान से सोचो एक और क्या इम्पैक्ट हो सकता है. Just think very carefully. What can happen? Very good, excellent. This can lead to the generation of the low pressure centers. So leading to generation of the cyclones. Very good. Clear हो गया एकदम? So during this phase there can be generation of the cyclones. So in a positive IOD condition there can be multiple cyclone formations. Low pressure center बन सकते हैं. So in such conditions it is also possible, that is across Arabian Sea region, there can be higher frequency of the cyclones in this region. Okay, so this can also lead to the low pressure centers and cyclones formation over Arabian Sea region. But nowadays lot of things are happening even in Arabian Sea region. We are witnessing, okay, very extreme level of the cyclones, which was not the earlier case. Now one associated phenomena is the rising sea surface temperature, okay, because of which we are witnessing higher frequency of cyclones in the Arabian Sea region. Simple, है ना? So it can also result into the low pressure centers, which can probably develop into, जरूरी नहीं है सारे low pressure centers cyclones बनेंगे, right? But it can intensify into cyclones. Okay, so we can witness higher frequency of cyclones in this year of positive IOD. Okay, so hence resulting into even further heavier precipitation, heavier flooding और हो सकता है अगर ऐसे cyclone formation हो गए तो. ठीक है, तो ये case scenario होगा. Now second case scenario, in that year only there is a El Nino. Okay, so second condition, there is also El Nino along with positive IOD. Now generally if the El Nino would have been there, then the precipitation would have been suppressed. But now because there is a positive IOD condition, so it would counter the impacts of El Nino. Okay, so El Nino along with positive IOD, so here IOD would counter the impact of El Nino. तो अगर कंपेयर करें, if there is only IOD, positive IOD, then there will be very heavy rainfall. If only El Nino, suppressed rainfall. Okay, but if both are present in a particular year, then in the case of El Nino, if there would have been a suppressed rainfall, now the rainfall is not as much suppressed. Okay, we would still have an average year of rainfall, because ऐसा होता है ना, शुरुआत में बोल दिया this would be an El Nino year, but rainfall तो normal हो गई because of this condition, right? But अब तो हर साल ही, एक साल El Nino होता है, एक साल La Nina होता है ना? कितना frequently हो रहा है? पहले इतना frequent नहीं था, कुछ भी हो जाता है. कहाँ पे रेनफॉल जहाँ होती नहीं वहाँ रेनफॉल हो रही है ना। गुजरात में अब कर्वेचर होके साइक्लोन्स उधर तक जा रहे हैं, पहले कहाँ होता था ये सब। और स्नोफॉल वहाँ पे भी हुई इस साल जहाँ पीछे 10 साल में नहीं हुई थी। लास्ट ईयर तो हुई नहीं स्नोफॉल, और इस साल वहाँ पे भी हुई जहाँ हो ही नहीं रही थी, लास्ट 20 ईयर से नहीं हुई, वहाँ पे भी स्नोफॉल हुई। इस बार तो बहुत हुई ना। अभी पढ़ा था कहीं अवलांच वगैरह का, कहाँ हुआ है अभी अवलांचेस? उत्तराखंड में चमोली में हुए ना अवलांचेस अभी। इस साल पढ़ा होगा न्यूज़, अभी करंट अफेयर्स पढ़ रहे हो कि अब बंद कर दिया न्यूज़पेपर? अब बंद कर दिया? नहीं तो उन्होंने भी तो पढ़ाया होगा ये तो पढ़ा होगा न्यूज़ में। अच्छा, ग्लोबल वार्मिंग है ना भाई, उसी के कारण से तो ये फ्रीक्वेंसी बढ़ रही है। वार्मर सी सरफेस टेम्परेचर्स हो रहे हैं कि नहीं मोर फ्रीक्वेंटली? यस, राइट। So this is the reason only. Now this is the condition of the warmer and the cooler one. Reverse में हो जाएगा negative IOD. So the conditions would be, this is the warmer center, ascending air, descending air. So low pressure center, high pressure center, okay, descending air, cooler water, warm water, descending air. So condition of stability, dry conditions. This is an example of negative IOD. Suppressed rainfall. Whereas enhanced rainfall over the eastern Indian Ocean. So here can be the reverse conditions, flooding हो सकता है etc. और यहाँ suppressed rainfall होगा, ठीक है। Maybe if with El Nino year can result into very dry conditions. Over India. Drought conditions हो सकता है, definitely failure of agriculture output, failure of crops हो सकता है, okay. So these conditions would persist in that particular year, okay. Now apart from El Nino, La Nina, IOD, so this is the negative phase of IOD, right? La Nina, El Nino we have already understood. There is another third one which they haven't asked till date, but they can always ask, which is called as MJO, okay, Madden-Julian oscillation. So MJO is another teleconnection which will impact, okay, so it also impacts different regions in terms of weather conditions, okay. Now see, when we talk about this condition, that is the Walker cell, is it static? Is the water cell static in terms of moment or not? My question to you is the Walker cell static in terms of the movement? Is it a coupled system which is static, or does it move from one place to another? Is it moving from one place to another? It is static. Only the direction is reversed. The pressure conditions are reversed, but it is static or not? Yes. It is not a moving system, right? So Walker cell is a static system in terms of the motion. ये system पूरा coupled system move तो नहीं करता ना, right? Okay, in terms of the movement, it is located across particular locations. So it is not in motion. Similarly, when we talk about IOD, is it static or not? IOD is static? Yes. MGO is a phenomena which is in motion. It is moving from one place to another. That is why it is not static in nature, right? So now what can happen is, again, so these are all ocean atmospheric coupled systems. Always remember this. These are ocean atmospheric coupled systems or not? Yes. Both El Nino, La Nina, IOD, they are ocean atmospheric coupled systems. Okay. So you can write down also, these are the ocean atmospheric coupled system. Now there can be a third one, that is MGO. But now in this case, what can happen? So assume it to be a very large system in proportions of the height and in proportions of the area. Okay. So across one limb there can be ascending air, and across the other limb there can be descending air. This is the low pressure center, ascending air. But it is extending, okay, up to great heights. So the extent is very high, large extent, okay, vertically and horizontally. Now this oscillation system that also develops as the ocean atmospheric coupled system. Okay, so this is also ocean atmospheric coupled system. अब देखो हमने क्या देखा, in case of La Nina, El Nino, IOD, these systems, they are stationary or not? Yes, but they are ocean atmospheric coupled system, but they are stationary. So the high pressure that is located here, low pressure is located here, they are stationary in nature. But now imagine this large extent of this oscillation system, and it is in motion, it is moving, it is not stationary, it is moving. Now when it moves, so let's assume these are the two limbs, okay. So this is the low pressure center and this is the high pressure center, right? So this is location A, this is location B. So across location A, what would be the weather conditions? Rainfall, precipitation hoga, ascending air hoga, right? And this is B. So currently B is undergoing which phase? That is suppressed rainfall, dry conditions. But now because it is in motion, so it would move. Now where is A? At the location of B. So now across A, B, what would be the conditions across B? Low pressure. So earlier it was witnessing dry descending air, high pressure conditions, but now it is witnessing ascending air, rainfall. So now because it is in motion, this coupled system, so it can bring both dry conditions as well as warm conditions. समझ में आ गया? So इसमें रेनफॉल भी होगा और सप्रेस्ड रेनफॉल भी होगा, बट ये मोशन में है. So 3-4 महीने में हो सकता है कि enhanced phase of MJ हो, and after 3-4 months there can be suppressed phase of MJ हो. Clear हो गया एकदम, right? So this is moving, this is in motion. This is not stationary, this is in motion. So this is, let's say, A and this is B. So after some time it will move, okay, and then it would witness this type of now this is across C. Across C now we are witnessing drier conditions. So B earlier, which was witnessing dry conditions, now is witnessing low pressure condition. Now rising air and precipitation. So this is because of this entire system, okay, which is in motion, it moves, okay, it is in motion. So again, MJO can impact the rainfalls or not? Yes, over India especially. So how it would impact the monsoonal rainfall? Let's say that the ascending limb of MJO is present over India. So how it would impact the rainfall? Enhanced. Enhance kar dega na? Heavier rainfall. Very good. So again, MJO, El Nino and La Nina and IOD, these interactions can also happen. So if the enhanced limb of MJO is there, so it can also lead to overcoming the conditions like El Nino, right? समझ में आया? एकदम क्लियर हो गया. अगर MJO है और El Nino भी कंडीशन है तो MJO की वजह से enhanced rainfall हो सकता है. So not as dry conditions as would exist. Okay, so just yes, it can enhance, right? It can enhance. मोशन में होता है, राइट? सो ascending limb, enhanced rainfall, and descending limb, suppressed rainfall. Now one question you had asked कि किस किस वजह से इम्पैक्ट होगा रेनफॉल पे, आप समझ में आया? Tipton low pressure is just one reason. Interannual variability can be because of many reasons. Now it is clear to us. So these are very important phenomena which impact the monsoonal rainfall. And they have been asked multiple times. El Nino पे question आया है? बिल्कुल आया है. Now it is clear? एकदम clear हो गया? ठीक है? अब कोई उसमें confusion नहीं है, right? Okay. So please understand one very important add-on point here is when we talk about the monsoonal rainfall across India. So there can be inter-regional variability. For example, across the Trans-Himalayas, across Rajasthan, across western slopes of Western Ghats, this is called as the inter-regional variability. And this rainfall variability because of these phenomena, that is called as the interannual variability. Okay. So this is the reason for interannual variability. This is clear? Okay. So interannual variability होगा, El Nino कम हो गया, like that. Okay. So I hope this is clear. This phenomena is clear, right? Next, when we talk about cyclones, okay. So we have already learnt, that is when we talk about the circulation of the winds. So two prominent forces which are responsible for the winds, that is first is wind, सबसे पहला pressure gradient force, very good. Second, Coriolis force, which leads to deflection. Okay, but now the third force, which can be the centripetal force, okay, around a low pressure center, which can result into the continuously rotating winds, resulting into the formation of cyclones. Okay, so what are cyclones? When we talk about the tropical cyclones, so tropical cyclones are the warm vortex, low pressure, okay, circulatory wind systems of tropical origin with closed circular isobars. So the isobars here are closed circular in nature. So when we talk about the isobars, so they can be straight isobars. So here the isobars are circular, closed in nature. Okay. So PGF So this is the low pressure center, 1016. So this would be the PGF. Okay. So here they are the closed circular isobars. Okay. So in bracket you can mention, because of the PGF, Coriolis force and the centripetal force. Okay. So cyclones are nothing else but the centers of low pressure surrounded by closed isobars having increasing pressure. So hence there is a pressure gradient outwards and closed air circulation. Okay, because the air that is converging in the interiors of the low pressure center. So convergent air circulation from outside towards the central low pressure. So that gives it the pressure gradient force and resulting into the cyclonic motion of the air. Simple as that. Okay. So hence we have these circular isobars. Simple. Okay. Next, tropical cyclones. They are also associated with stormy conditions, okay, that originate over oceans in the tropical areas and move over to the coastal areas, bringing about destruction and violent winds. So hence they can result into very heavy rainfall also over the coastal areas. Okay. Now very heavy rainfall can be associated with a term that is called as the storm surge. Okay. So this is the term which is called as the storm surge, which can result into very heavy rainfall over the coastal areas. Okay. So this closed air circulation is because of the rapid movement of the hot air and which is subjected to the Coriolis force as well. Okay. And they are the irregular wind movements involving closed circulation of air around the low pressure center. Now what are the conditions why this low pressure center is generated? First of all, because of the sea surface temperature that should be higher than the 27 degrees. Okay. Now this is also associated with the rising frequency of the cyclones over the Arabian Sea region. Across the Arabian Sea region there are concrete reports that is the sea surface temperature has increased. अब ये prove हो गया है, अब इसमें कोई doubt नहीं है. Okay. And on an average they are saying that, okay, in the past century or so it has been almost by 1 degrees. So if there are concrete evidences, that is why the Arabian Sea region is witnessing more number of cyclones. Earlier it was where? Bay of Bengal region, but now it is increasing across the Arabian Sea region. Okay. So ocean waters having the temperatures of 27 degrees or more is the source of moisture, okay, which feeds the storm. The condensation of this moisture releases enough latent heat of condensation to drive the storm. So hence because of the moisture which is available here, it is generated on the waters, right? Now very importantly, the cold currents lowers the surface temperature of the eastern parts of the tropical oceans. Okay. Now when we talk about the eastern parts, so we have just learned that there is a presence of the colder waters or not? Yes, there is piling above the warm waters where? Across the western parts, right? So hence making them unfit for the breeding of cyclones. So that is why there is absence of the presence of the cyclones over the eastern waters. This is clear, simple method, right? Okay. And exception can be during the El Nino years. So during the El Nino years, what would happen? The Walker cell would reverse. So when the Walker cell would reverse, where would be the piling up of warm waters? ये point समझ में आ गया कि नहीं हुआ? Clear हो गया एकदम? Yes, generally they are not formed. ये clear हुआ कि नहीं point? India के case में Bay of Bengal, that is more associated with the enclosed nature of the water body, right? Okay. Now see, in a normal year, what I am trying to say is, so this is the eastern portion, right? And this is the western. So in a normal year, generally क्या होगा? Eastern waters कैसे हैं? Colder है कि warmer है? Simple. Colder है. और ये क्या है? Warmer है western ocean waters, right? So इसी के कारण से the ambient sea surface temperature which is required, that is not present for the formation of cyclones. That is what I am saying, right? But when there are the El Nino years, now what would happen? The Walker cell would reverse. So where is the presence of warmer waters? Okay, which is shown in the pink color, right? Eastern water. So then there can be the formation of the cyclones, right? So this is what it is mentioned here. That is, the cold currents lower the surface temperatures of the eastern part of the tropical oceans, making them unfit for the breeding of the cyclonic storms. Clear ho gaya ekdam? In case of India, the presence of this enclosed water body, right? Bay of Bengal ka aisa nature hai, that is topographical. That is why it is having the enhanced number of the cyclones. Wahan kyun cyclones zyada hai, right? That is the case scenario. Next, presence of the Coriolis force. So we have learnt this, where there is absence of the Coriolis force across equators. Okay, so across equator there is absence of the Coriolis force, resulting into absence of even the cyclonic storms. Simple as that. Okay, and always remember the Coriolis force is a proportion of the angle. Okay, angle of the latitude. So at the latitude the angle would be 0. So that is why there is absence of the Coriolis force. And because there is absence of the Coriolis force, will it form the cyclones or not? No, because that is a necessary condition, right? Enough to create a cyclonic vortex. So across equator, no cyclones at equator, and because of the 0 Coriolis force. Okay. Then small variations in the vertical wind speed. That is the wind shear. Now see, if the wind shear, if there will be very high variations, then it would dissipate very quickly. बनेगा ही नहीं, वो storm ही नहीं बनेगा, right? So hence this condition is very essential. Then a pre-existing weak low pressure area or low level cyclonic circulation. So this low pressure center, see, it may also dissipate. If it does not intensifies into a cyclone, it can also dissipate. But if it intensifies, then it can lead to the formation of cyclones. Okay. Then upper divergence above the sea level, which is simple. Because here what is happening? Convergence. This is the convergence center, right? So upper air divergence. So this should sustain the entire system. That is why the lower level convergence and the upper air divergence. So that is what intensifies the cyclone over a period of time. But nowadays many things are happening to cyclones. It can also become a recurvature cyclone, etc. All of which is more associated with the climate change aspect, right? So that is the concept associated with the cyclones. Now see, in wake of climate change, we are witnessing more number of frequency of cyclones across the Arabian Sea region. Okay. So what can be some of the implications? Yes, very good. Yes, so I am asking you what can be the some of the implications. There are applied questions also which are asked in your MCQs. So पहला मैंने एक question बोला, if the frequency of cyclones is increasing in Arabian Sea region, what can be the implications? Think on that. Okay. So this region, Arabian Sea region, is witnessing higher frequency of cyclones now. So one, you are saying that higher proportion of rainfall. What else? Okay, cyclones over those areas where they earlier were not present, which is fine. Or bolo, think about it. Settlements in the coastal areas. Flooding hoga ki nahi? Yes. What else? Think और सोचो. Coastal areas में क्या होगा? Subduction होगा, maybe with the rise of sea level further. Okay, let's take it. Okay, so coastal areas erosion, and later on with the rise of sea level, subduction. What else? What will be the immediate problems? Varied dimensions is 8. डिजास्टर्स, वेरी गुड, डिजास्टर्स विल इंक्रीज, राइट. डिजास्टर अभी तो बोला स्टॉर्म सर्ज वगैरह ये सब बढ़ जाएगा, राइट. सो दैट वुड लीड टू इनंडेशन ऑफ द कोस्टल एरियाज. अब सोचो और क्या होगा. हैबिटेशन सेटलमेंट्स हमने लिख लिया, और disasters, what else? Migration, what else? Think sectorally, और क्या क्या बहुत मेजर इम्पैक्ट क्या होगा सेक्टोरली सोचो. दैट इज व्हाट आई एम आस्किंग, थिंक ऑफ इट सेक्टोरली. और क्या इम्पैक्ट होगा. नहीं नहीं उतना ब्रॉड नहीं, एकदम उस पे जाओ, बिल्कुल उस पे पिन पॉइंट करो. हाँ कैसे होगा और बताओ सेक्टोरली. बायोडाइवर्सिटी पे इम्पैक्ट होगा, वेरी गुड. एग्रीकल्चर पे, कोस्टल एरिया एग्रीकल्चर. अब एग्रीकल्चर पे इम्पैक्ट होगा, इसको भी एक पॉइंट देखो. वहाँ कोई स्पेसिफिक फार्मिंग सिस्टम पता है इस कोस्टल एरिया में, पर्टिकुलर फार्मिंग सिस्टम जो स्पेशल फार्मिंग सिस्टम है, विच हैव बीन गिवन द GIHS टैग ऑल्सो अक्रॉस दिस वेस्टर्न कोस्टल रीजन. कौन सा एक फार्मिंग सिस्टम जिसको GIAHS टैग मिला हुआ है अक्रॉस दिस रीजन, अक्रॉस दिस कोस्टल एरिया. GIHS कौन कौन से इंडिया में, ये याद आ रहा है. हाँ सेफ्रॉन, वेरी गुड. नहीं आई हैड आस्क्ड हिम कि कौन कौन से. एक सेफ्रॉन है, वेरी गुड. कोरापुट है एक, और एक और कौन सा बचा, थर्ड कौन सा बचा कोस्टल एरिया में, इसी कोस्टल एरिया में. कुटानाड फार्मिंग सिस्टम, वेरी गुड. यस कुटानाड फार्मिंग सिस्टम है ना. ये तो मुझे पूछना है, तुम तो मेरा ही टेस्ट ले रही हो है ना. मेरे अटेम्प्ट तो हो गए भाई, अब मैं कंपटीशन नहीं हूँ, ठीक है. सो कुटानाड फार्मिंग सिस्टम, राइट. सो जस्ट टेकिंग अ क्यू फ्रॉम योर कुटानाड की बात हुई तो राइस फिश फार्मिंग सिस्टम्स की बात हुई. फिशरीज विल बी इम्पैक्टेड और नॉट. व्हाई यू आर नॉट सेइंग दैट. When the warming of the sea surface temperatures would happen, there will be two case scenarios. First case scenario would be impact on the productivity of the fisheries. Second, migration of the species. Now is it happening? Definitely it is happening. Migration of the species of fishes from Indian Ocean northwards. ये तो common phenomena हो रहा है. Yes, that is Anthropocene. उस पे भी तो पूछा हुआ PYQ है, सीधे ये पूछ लिया था एंथ्रोपोसीन क्या है ना. अब देखो कुटानाड फार्मिंग सिस्टम, राइस फिश सिस्टम, इम्पैक्ट ऑन फिशरीज. नाउ वी वर स्टडीइंग द कंसेप्ट ऑफ साइक्लोन्स. क्वेश्चन कहीं से आ गया ऑन राइस फिश सिस्टम एंड कुटानाड. अब आप एकदम सोचते ही रह गए ये क्यों हुआ. कहीं नहीं हुआ, आपने लिंक ही नहीं बनाया. दिस इज द प्रॉब्लम. आप समझ रहे हो. आपका अप्लाइड जो डायमेंशन है उसको स्ट्रॉन्ग करो. हम जो भी चीज़ पढ़ रहे हैं, ओके, द कंसेप्ट्स दैट वी हैव स्टडीड टुडे. नाउ टुडे वी हैव स्टडीड टेलीकनेक्शंस फॉर एग्जांपल. नाउ फाइन, यू नो द सिस्टम, एवरीबडी वुड नो व्हाट इज एल नीनो IOD नाउ, राइट. नाउ you know what are the factors resulting into monsoons. Now in a particular year, for example, we discussed the low pressure system, if it is further weakened because of the excessive snowfall, right. Now create the other conditions, what will be the impacts, like that, and then what would be the further repercussions. Then you study that entire topic holistically. Now if in news there is any particular news कि climate change की वजह से ओके बायोडाइवर्सिटी कैसे इम्पैक्ट होगा, क्योंकि इस एरिया का हैबिटेट चेंज हो जाएगा ना. सो एक कौन से स्पीशीज होंगे जो वहां मिलते हैं वेस्टर्न घाट्स में. एक तो वो स्पीशीज हुए विच आर फाउंड हियर, राइट. अनदर कैन बी ऑल्सो माइग्रेटरी स्पीशीज. देर आर मेनी सच प्लेसेज इन इंडिया वेयर सच atmospheric circulations have changed and where the migration of species has stopped. Do we know of them? Yes. Across the eastern coastal plains there are so many migratory species which are not migrating now because of the impact on the habitat. कोलेरू लेक की स्टडी बहुत बार आ चुकी है, समझ में आ रहा है. आपका नॉर्दर्न जो हिमालयस, ट्रांस हिमालयस है, वहाँ से बहुत बार ये रिपोर्ट्स आते हैं ब्लैक नेक क्रेन को लेके. दिस इज बिकॉज ऑफ द चेंज इन द हैबिटेट, बिकॉज ऑफ द चेंजेस इन द atmospheric circulations. So this is just one example which I have given you. Across the coastal areas, how the habitat is changing, which is impacting the biodiversity. Will it also impact the vegetation here? Yes. How it will impact the vegetation? आप सोचो, क्या क्या सोच सकते हो? Submergence of islands, very good. तो कोस्टल एरिया सबमर्जन हो सकता है, वेरी गुड, है ना, वेरी गुड. और वेजिटेशन पे सोचो क्या इम्पैक्ट होगा प्रोमिनेंटली. डेफिनेटली कोरल्स पे भी होगा, वेरी गुड, है ना. चलो PYQs ऐसे ही बनते हैं बच्चों, हमें समझता नहीं है ये क्वेश्चन कहाँ से आया था. आप समझ रहे हो, आप क्वेश्चन पेपर का एनालिसिस करो, ठीक है, एक कोई भी PYQ उठा लो और कर लो, आपको पता लग जाएगा कैसे क्वेश्चन बनते हैं. दैट इज व्हाई आई एम गिविंग दिस एस्पेक्ट टुवर्ड्स द लास्ट. आई वांटेड यू टू अंडरस्टैंड हाउ द क्वेश्चंस आर फ्रेम्ड. ये तो सिंपल है ना, अगर मान लो कोई स्पीशीज इन न्यूज़ थी, उसी के ऊपर क्वेश्चन बन गया तो वो तो सब करेंगे. बट जो अप्लाइड क्वेश्चन है वो किसी किसी के क्यों निकलते हैं, ये भी तो वेरिएशन है ना. किसी का प्री निकलता है 130 से, कोई 90 पे बैठ के कैलकुलेट कर रहे हैं मैं बॉर्डर पे हूँ, क्योंकि हम अप्लाई नहीं करते. आप समझ रहे हो. वेजिटेशन पे बोलो और क्या इम्पैक्ट होगा. बेसिक थिंग सोचो, बिल्कुल बेसिक बात सोचो, क्या होगा. राइज इन सी लेवल हो रहा है, अगर इनंडेशन ऑफ दी सी वाटर अगर हो रहा है, तो व्हाट वुड हैपन. दोज वेराइटीज विच आर नॉट सॉल्ट टॉलरेंट, इमीडिएटली अब वो एरियाज विल नॉट बी फिट फॉर कल्टिवेटिंग दो स्पीशीज विच आर नॉट सॉल्ट टॉलरेंट. सो दोज क्रॉप्स विच आर नॉट सॉल्ट टॉलरेंट are no more suitable. Okay, so that is why we are now practicing more and more climate smart agriculture varieties in context of heat resistant, salt resistant, drought resistant varieties. Why? और फॉर एग्जाम्पल मानो कोई ऐसी स्पीशीज, ठीक है, कोई भी ऐसा क्रॉप वेराइटी अगर अभी न्यूज़ में था तो आपको क्लिक नहीं करेगा. Now this is the linkage that I wanted to develop. आपको थोड़ा ब्रॉडर पर्सपेक्टिव से सोचना है. अब कौन सी स्पीशीज यहाँ सूटेबल हो गई. मैनग्रोव्स, वेरी गुड, एग्जैक्टली. Now I would tell you one news. Very recently, you can go and search. From past 1 year, multiple articles were published with respect to restoration of mangroves across Gujarat coastal area. अब लिंक बना, किसी घूम के आए पर लिंक बन गया. तो there is now a severe restoration program which is being taken into consideration across Gujarat coastal area. गुजरात गवर्नमेंट इसको अब कर रही है, taking into consideration increasing number of frequency of cyclones, and that would also revive the habitat. Exactly, right? So that is why ये गुजरात में न्यूज़ में रहा है. Restoration of mangroves. I hope now all these perspective is clear. Yes, Atish, very good. Kutanat rice cultivation, very good. Okay. So I hope this discussion, okay, you understand now what is the perspective that I am trying to develop. Don't read any topic only from the perspective of static knowledge. वो तो concept है यार, अगर एक बार आ गया आप भूलेगा नहीं, बट उसमें interlinkages develop करो. अब ऐसा होगा तो क्या होगा, if this would happen then what would be the scenario. Believe me, it would give you a leap of at least 5 to 10 questions in your prelims. Believe me, वो पक्का होगा, है ना. बस न्यूज़ को हम पढ़ना सीखेगी, वो किस पर्सपेक्टिव से हमें पढ़ना है, राइट. सो येस, दैट इज द पर्सपेक्टिव फॉर टुडेज क्लास. आई होप यू अंडरस्टूड द कंसेप्ट्स, एवरीथिंग इज क्लियर, राइट. बट इफ समथिंग इज नॉट क्लियर, यू कैन मीट मी आफ्टर द क्लास एज वेल. कोई क्वेश्चंस नहीं समझ में आ रहे तो आई कैन ऑलवेज डिस्कस, ओके. एंड फॉर द स्टूडेंट्स who are attending it online, we are starting with the Geography Optional Foundation from the 28th of March. And you can contact the office number for further details. Okay. So that is all for today's class. Okay. I hope everything is clear. Chalo. Thank you.